Hello and welcome. Welcome into our webinar series for this one titled BIM and Interoperability. I'm very pleased to see you all here joining us. My name is Mo Al-Gidey. I'm a BIM Bridge Research Engineer here at Alplan. For today, we're going to focus, as the title indicates, BIM and Interoperability. But we will make our starting point for the discussion or for the webinar, the ISO 19650 information management process. So let's start in. We have, as indicated, the ISO 19650. Specifically the diagram which shows the appointing party, the responsibilities or duties of appointing party, and also the appointed parties, what they have to do, which tasks they should have to fulfill, and finally we have the, of course, also the appointing party, what they require or what at the end of the day, what they should receive. Here, just to give you a quick recap, because we are going to jump in detail and have a look into all these processes that we have. But just to give the general overview, we have here an appointing party. Maybe I'll just change the cursor here so you can see much better. Here we have the appointing party. And we have the appointed party, this list of tasks that they need to perform. And of course, we have at the end of the day, the appointing party back. The appointing party, they can start with the requirement. So these are a set of wishes and basically requirements that the appointing party or the client wants to be fulfilled by the end of the day. So here we are calling them exchange information requirement. But basically they are requirements which the appointing party sets, because those are the steps into the deliverables, or basically they are also deliverables. Once the appointing party has identified and defined these requirements or the exchange information requirements, the appointed party has to fulfill those things. First, before tendering process starts, or before the tendering has been appointed or selected, the appointed party set of different appointed or candidate appointed parties, they tender or they participate, and they provide a set of BIM execution plan. So they can provide BIM execution plan prior to being appointed. So while they're in the candidate, they can set up BIM execution plan, basically saying if we win this or if we take the project, we will do that requirements based or like by using this kind of approach, by using this framework, or by using this tool, BIM tool, authoring tool, designing tool, or so on and so on. So they specify all the plans, how they are going to achieve the requirements which are set by the appointing party. So this, they set it before being appointed. Once they're appointed, of course, they will also set up again the BIM execution plan. Maybe now in much more detail. So they set up all how they are going to achieve the requirements which was already defined by the appointing party. The appointed party then moves on to, of course, defining the BIM execution plan much more in detail. This is after being appointed. Then they move on to the BIM modeling. Then they do the quality checks and controls and assurances, basically to the models that they have done. And of course, they can also draw, of course, while you do the quality checks and controls, makes much more sense to draw lessons from that, right? So what they have learned, or what were your mistakes, what you should avoid, or what you have properly done. Here, lessons learned not necessarily means notes that you have to take, but it could also mean templates that you save, workflows or shortcuts, or even automations all these things that you can save and you can reuse later, this could be classified as lessons learned. So the appointed party learns from what they have done, and based on the qualities of their work and checks and so on, they of course can draw a lot of lessons from that. Once they did the lessons learned and the quality checks and control, they start to work on the information delivery. So basically how they are going to deliver it. For example, let's say the BIM execution plan, the required or in the requirement and the exchange information requirement, the appointing party has set the requirement that the deliverable should be IFC. So the appointed party in the BIM execution plan, they can say, okay, we're going to use Allplan 23 because it supports an IFC export. Using that, we will export an IFC at the end of the day. So once they did the modeling and so on, at the end of the day, they have to deliver it as an IFC. And because they have already specified to use Allplan to deliver the IFC 4.3 or any IFC for that matter, then they can deliver that. Once all the information is delivered, based of course all this on the assumption that the appointed party has fulfilled all the requirements that was already set by the appointing party. Once they have delivered the information, then they start archiving. The appointing party, because they have received all the information, the appointing party starts archiving all the information, basically the FC models, drawings, reports, any other information which was set or required by the appointing party. So they start archiving. Then of course, while they archive, they can also draw lessons. So they can draw, okay, maybe it was not necessary to set this requirement that we already set at the beginning. Or maybe for next time we forgot to set this, that, because these are quite necessary to archive a project, archive, retrieve, and of course basically reuse it. So for those steps, for those functionalities, maybe they needed more things. So in that case, they also draw lessons learned. So here we are saying, okay, lessons learned could be drawn by the appointed party. And of course, lessons learned could also be drawn by the appointing party. So basically they both learn and grow while they do their tasks. If we go in and dive a bit in detail, not so much in detail, but just a bit, just the surface, to see a small example how everything could look like. So let's start with the appointing party. The appointing party starts with the set of requirements. So they have a naming style they wish to have, maybe a units. Of course, this makes quite a lot of sense. They might say, okay, you use for every length measurement millimeters, for logs maybe kilonewtons, and so on. So they set up the units. Maybe this could be a requirement. Or maybe they could say, okay, we need IFC 4.3. So since this has become kind of now the new standard for infrastructure projects, so they could have set this as a requirement. And from their lessons learned, maybe from previous projects, they have learned that, okay, adding this attribute 1 and attribute 2 are necessary. So they could also add this as additional requirements and saying, okay, so into every model, to every project, to every object model that you have in the project, please add attribute 1 and attribute 2. And for only the peers and the pies, please add the peer ID. So they can say such things. And they can of course also define or specify the minimum level of detail, or even the exact level of detail that they want, or level of information that they want. So all this could be specified in the appointing party. So these are just a few examples that could be done as that could be set as requirements. But of course, the more could follow as well. So here, the appointed party, let's assume there is tender and party B or party C has won that, and now they already did the BIM execution plan pre-tender or pre-appointment, and now they are during the tender. I mean, now they are they won the, or they have been selected or appointed, and now they have to do the BIM execution plan again, or more in detail now. So what do they have to include in the BIM execution plan? Basically, in the BIM execution plan, they have to specify the framework that they need to follow to execute the set of requirements which were already set by the appointing party. Such as, okay, the naming style. So they said, okay, we have to use only characters or letters. Okay, we can achieve this by having this kind of example, or for having this kind of naming style. For example, the FC 4.3. So how are they going to achieve, or how is the appointed party going to achieve or provide the FC 4.3? Here they say, okay, we're going to use Allplan 2023 because it supports FC 4.3. So we're going to use Allplan 23 to provide FC 4.3. And this set of attributes, okay, maybe defining for each object might not be so easy. So they can say, okay, we're going to use a visual scripting in Allplan, and we can set for every or each peer the peer ID, and for all basically we can use the attribute sets, and we can assign every object that we have in the project. Basically they say, or they specify a plan to how they are going to execute the requirements which are set already by the appointing party. So this is the plan that they include in the BIM prior to starting any work, which is called the BIM execution plan. Afterwards, we have two milestones. The first is the modeling. The modeling, basically, let's call it modeling, and the second is the deliverable. So how they deliver the information. And here we divided them into two milestones because this could be two milestones. The reasoning is that so for the modeling part, for example, let's say you model the pier. Once you model the pier, you have to check that quality, and once you check the quality, while checking the quality, basically you learn or you can draw a lesson. You can say, okay, next time if I have a pier, I should model it this way. Or you could also just save the cross sections that you have used to model a pier. So this is also a lesson that you have drawn from this mini task that you have. So basically for the modeling part, you can directly draw or you can directly do the quality checks or quality assurances, and from that you can directly draw lessons. So this is the first milestone. Then you jump into the second part, the second milestone. Basically this is the information delivery. So how is defined in the BIM execution plan, but here we the appointed party, they start to work on delivering the information. So if IFC was wished or required, they start producing IFC. If for example drawings are required or layouts, they start working on that. So they specify all they start working on the information delivery, which was already specified on the BIM execution plan, which was already also defined prior in the exchange information requirement by the appointing party. Then finally, the appointing party, they draw lessons, they start archiving. So this is the last part. So this was kind of the introduction into our webinar. We are going to jump into these two milestones. The first milestone, this one, and the second one, this one. But in case if you have any questions, comments, feedbacks, please feel free to use the chat box that we have. You can write there and we will get back to you with the response. And you can also use, of course, our email, and you can immediately write us, and we will try to provide you with the response as soon as possible as well. So let's go back to the first, or not go back, let's start with the first milestone. The first milestone is the modeling, quality, and lessons. So here they are included in one milestone because it makes much more sense to do the modeling of any given object, and to check the quality, or to do the control for that object if the model is according, and to draw the lessons out of that. So the first step in setting up or in starting the modeling is setting up the project. Here we can set up a project in Outline. So here we have a BIM and interoperability. This is a project. We can set up the project setting, for example, the offset coordinates, if wished, also a currency, and we can also start assigning attributes. Here we're saying the architect is Mo Al-Gidai, and we're saying, okay, the client is Allplan, so we're saying that. And we are also, if wished, we can also add additional attributes. Here we have a general list of attributes that we can use to define our project. So this was done in Allplan. But here we have, we might have a bridge project that we want to include in all this Allplan project. So we can have a bridge. Let's say we have a bridge from set of station 1 to station 20. So in that area we need to add a bridge, and in that we need to add a bridge project. And for that we need also to define the setting for that bridge project. And here we have a set of units we can choose. We can also choose here the bridge type, because this is a FC 4.3 compatible, so meaning that we have the possibility to define the bridge type and also the other new taxonomies or new definitions which are included. For this one we said, okay, it's IFC girder, IFC bridge type girder, because we say we want to build a girder bridge in that specified station. Yeah, here we're then move on to adding attributes or informations basically into our model. Here maybe what as a step we skipped this part is that we're not showing here the modeling steps, how to model this kind of bridge, but rather we assume that this could be done, but we focus more on the attributing side, how to add the information or how to attach the information, or basically how to provide or give meaning and sense to the objects that you're modeling. Here we have a hollow box girder, and this girder box is going to be used to create this extruded shape here. And this cross section has the possibility, in the cross section we have the possibility to add the FC type and the FC object subtype. So basically we say the FC type is FC BIM, and the FC object subtype is main girder BIM. So we define that and we say this is the IFC object definition. We can do this for all the cross sections that we're using across our project. So for example, for the pier that we might have here, we have a cross section, for example, for example, shaped I don't know, stadium, or rectangular or circular, doesn't matter, but for that cross section we specified the IFC definitions, object definitions. But in the new one, in the 4.3 IFC schema, we have the possibility to add the bridge part type. So basically this means the IFC facility part type. So this could be the same as saying, okay, we have the whole bridge project, so how do we divide it? So we can divide it by using this bridge part type, saying, okay, we have piers here, we have abutments at the end, we have a superstructure at the top. So basically we divided this whole bridge project into 3 parts. So for that we can have this possibility to add the FC bridge parts type for each girder or for each pier object that we have here, and say, okay, this is FC bridge parts type, and we specify what type of which definition it is. And since this is a pier, we say pier we have here, and we can specify it here and here. We have the FC bridge parts pier assigned for these 2 piers. But of course you can also do the same for the others, and saying this is an abutment, this is an abutment, and this is a superstructure. So this is like the the other way of approaching the one that we have seen previously. The previous slide we said, okay, we have this bridge project and how can we divide, or how we can break down the bridge project. This is a special classification or breakdown of structure, basically on IFC 4.3 schema. But we have a feature which is called custom tree in Allplan, and this is, I think, released last year in the 23 version. And in that version, you can basically break down the bridge project as you wish. So maybe you can say, I only have 2 parts, superstructure, substructure, or you can say I have 3 parts, superstructure, abutment, pier, or maybe you can just say, okay, we have some, I don't know, some stationing or some other way of classifying or breaking down the bridge structure. But here we're using a custom tree, which is also compatible, or which also follows the IFC 4.3 schema. So here we are dividing the bridge project into superstructure, abutment, and pier. Then this is, of course, transferred from Allplan bridge to Allplan, and you can see in the building structure we have these objects assigned in different drawing files. When this is coming back to the first or second slide, but basically when we said that sometimes the clients or the appointing parts, they wish for more or additional set of attributes. So those attributes which are not defined or which are not found in the default definition, they can be defined by the user. So the user can come and say, okay, we have set of attributes and we want to define them. So they can add the definition here under the user here. Here, for example, we have an attribute called attribute 1, and it has text. Basically, it's a text data type, and it has no comments, but basically you can also add a user defined comment and so on. So this is one attribute that the user defines. So that was like a workflow to show you that you can define an attribute and assign it. If we go back, we can assign it directly to this peer here and to the other one as well. So we first define it, and after we define it, we can transfer this attribute to the other objects that we wish to have. Here what we have is also here a bit more automated, or a bit more or actually not a bit more, but a better workflow is that, okay, if you have a set of objects and, for example, we have a peer, we have 2 peers, but we can have as many as we wish, but we have peers, let's say, and we want to assign them an attribute specifically for peers. So we can have a peer ID which specifies only for peers, and we can have peer attributes which only specifies for peers some value. Here, as you can see, we have the first peer, but the peer ID and attribute that we defined are not there. So what we do is we go to the project setting here, and we can come and we can have our own attribute set definition. What we're doing here is that we are selecting, okay, for every column, or basically for the peers, we want to have our own additional peer common attribute sets. So here we have a peer ID and peer attribute. These 2 attributes are going to be assigned to every peer that we have. So we have my peer common, this is assigned for the first peer. We have my peer 2 here, and the second peer, for that we have also my peer common 2. So we have defined the peer sets or peer related attribute sets just for the peers, and you can do similar thing to the other objects as well. What this does is it saves you quite a lot of time, as it automates quite a lot of work. Okay, so we are talking about the modeling quality in lessons. While we do the modeling, for example, we did just model the 2 peers here and there, and we want to check if everything that we did is correct. And that meaning that we want to check the geometry, we want to check also the attribute or the information attached to the geometry. So we can, for example, quickly generate a report only for the peers, and we can check if everything is according to the plan. We have the first peer here and we have the second peer here, and we check if, okay, these are the wished or the correct definition of the IFC object for the peers. So these are column, so it's okay. We have attribute 1, but which is only assigned to the attribute to the first peer, but not to the second one. So there is one red flag here that we need to check. We have attribute 2, which is defined for balls, but it has a value of 0. So this is kind of a red flag as well, because we need to check if it's okay or correct. We have also a peer ID here, and the peer ID is also assigned for balls, but still the value is 0, 0. So we need also to check that. So by just quickly generating a reporting, we can easily go through and check. So at this point, it might not seem that much impressive, but imagine, let's say you have quite a number of peers, or let's say we're working on piles, and we have quite a number of piles, 20, 30 piles for maybe for each peer, around 6, 7 piles for each peer, and we might have number of peers, and thus we will have quite a number of piles. And checking for each pile if everything is correct, or for every definition that we set is correct, could be tiresome. So for that, we can easily generate a report, and using this report we can check, okay, peer, I don't know, pile number 2 of the first peer has something wrong, so we need to check that. So we can basically do that for all the peers, for all the piles in each peer, and this of course saves quite a lot of time. The second way we can check the quality, or of course the quality control or the quality assurance, is visual scripting. Maybe you might be asking, okay, before I go to the visual scripting, okay, we did the modeling, why not export the model and check the quality in any other or third-party products or other products which are specifically created for checking the quality? Of course, it's possible, but at this point we were saying, okay, from the modeler perspective, they can also just check some of the work that they are doing. So basically they are, as the programmers said, they are debugging their work, so they check if everything is according to the plan or to the requirement. So here they can use a visual scripting and check if everything is okay. So this visual scripting, what it does is, this is just a zoomed version of this one. What it does is it filters all the objects using an attribute ID 1444. Basically, this is the FC object subtype, and the value of this FC object subtype, if it's a column, please color it green. So as you can see, only these two tiers are colored green. This is because these two are the only objects in our bridge project that have IFC object subtype value of column. So basically we can filter around and we can color them. So like I said, like in the previous example, let's say we have a number of peers. It might be quite hard to check if everything is okay, so we can easily just apply color coding filter, and it will check if everything is accordingly done. For this one, let's just see how it was done. Basically, we have 6 nodes, and what they do is this one is for attribute selector, so it selects all the objects. From all the objects, it checks the value, the attribute value for the attribute value for each object, and if it's as the specified, for example, as a string value column here, and we provide that condition or that value condition, and we kind of say at the end of the day, okay, we want to color it. But if you don't want to color it, maybe you want to change, I don't know, the layer or the stroke or any other format, you can apply to that object. But basically you're filtering out the objects which don't comply to the requirement that we have specified, or that to the requirement that the appointing party has specified, but you as a appointed party, you have specified the BIM execution plan, so you have to make sure everything is according to that plan. These were 2 quality checks or quality controls, but mostly focused on the information aspect of the model. But of course, we can also do a hard check, basically like geometrical check, where, for example, we have 2 3D solids, one cube 2 here, and we check if everything is okay. So we can have, for example, a check, and we can say, okay, these 2 are colliding, so there is one collision here. So we're checking between 2 3D solids. And you can do the similar thing with other objects or with other geometrical definitions, but basically the concept is we're checking for collision. So this is of course also quite important, as it allows you to make sure everything that you did or you're doing is accordingly. So we come to the second milestone. The second could be also the third milestone if we count the BIM execution plan as the first milestone. But let's say this is our second chapter in our webinar. So here we have the information delivery. And of course, just a quick reminder, comments, feedbacks, questions, please feel free to write them in the chat box. And you can of course also send us an email and we'll get back to you as soon as possible. So let's come back to the information delivery. So how do we deliver the information, which we already did model or design, but for example, let's say the requirement is an IFC or in different file formats. So how can you do that? So let's say I want to here start with the analytical model. So how can we share analytical model? Because I feel there are not so many workflows or literatures on that to show or how analytical model can be shared or can be reused. From openBIM perspective, there are two ways to share analytical model. The first one is to use a TCL scripting, basically because we use a TCL or openBIM supports a TCL, so you can use a TCL scripting to program or to write out the analytical model into different file formats. Or you can also just use BIM+, BIM+ because it has an open API. Using this open API, it could be fetched into different analytical solutions. If we just try to look a bit more in detail into the two workflows we have, and we start with the TCL scripting. So this TCL scripting, the idea is we have a bridge project, and from that bridge project we've created the analytical model already, and here is just one model actually in openBIM. So you have one model, and from that one model you can create the geometrical model, of course, and also the analytical model from that one model. And from this model you can create the analytical model, and this analytical model can be exported using a TCL. The first is using the out-of-the-box support for RM Bridge export, so you can use that directly from openBIM, and you can export the file or the analytical model in RM Bridge. Second is, maybe this is a new feature which is going to be released in the 24 version, but this will allow you to read or write from the database, from the openBIM database, and export the TCL, export using a TCL the information of the analytical model. So for example, maybe the loads, the connections, the cross sections, and so on and so on. You can basically write your own TCL, small TCL, and export it into any file format that you want. Maybe you want it in a CSV file format, you can do that. You want it in any other format, you can basically do it. But you have the possibility to do so using the TCL scripting. And the second way, or the second approach, is to share via BIM+. So in BIM+, like I said, it's an open API platform, so you can use that to share the analytical model to other third-party softwares. For example, we have the connection to Midas, you can use that, or you can also use a SAF file format directly from BIM+. SAF is the structural and analytical file format, which will allow you to import, which is supported by few, or not few, but many actually, analytical solutions such as SIA, Sophistic, and so on. So basically from BIM+, you can export to SAF file format, and from SAF file format you can import it to Sophistic, SIA, and so on. Yes, and there is also the IFC, and we have the IFC analytical model which you can export from BIM+, but this stage, as it's not mature yet, it might take some time, but overall there is also that approach. So when IFC analytical models is supported widely or accepted widely, you can also use the FC analytical model to export an analytical model. If we say that's about the analytical model, let's see what we can do with the geometrical model. So here, just going to focus on the FC 4.3 as this is a new one and most relevant one to bridges and infrastructure projects. So we're just going to focus our discussion to FC 4.3 here. Just few information regarding FC 4.3. So what's new is that there is an enhanced definition of the spatial structure. Basically, we talked about this. The core idea behind this is how do you break down a bridge structure. So here we have a definition of bridge part type and bridge part. So we can use this to break down our bridge. And we have also improved infrastructure domain taxonomy. So we have a new terms that better explain the domain, basically the infrastructure or the bridge project or road project. And in terms of the geometry, we have also here, as indicated, more enhanced definitions. So more complex geometries such as sweep and so on are better supported in the new version. Here we have the IFC export from Allplan. Basically here we have the option or the possibility to export the IFC. And we have different options or exchange profiles. And as you can see here, we have FC 2.3, we have FC 4, 4.3, and so on. We can choose which one we wish, and we can basically export the bridge project as an FC. Maybe just here to remind you, we specified in the building structure, or basically in the custom tree, that the building structure should look like this. We also have specified in the IFC bridge part type, basically the IFC facility part, and we divided our bridge project. And we said, okay, for the bridge project, we have two abutments, we have piers, and we have superstructure. So we basically broke down the bridge project as such. And finally, you can see it in that way. So coming to the conclusion, here we are going to conclude our webinar and close out. But before so, I just want to remind you, for questions, comments, feedbacks, please feel free to use the chat box, or you could also send us an email. So coming to the conclusion, here we can use any of the products. And if I change 1 second to the cursor, here we have Allplan BIM authoring solution, and we have a BIM Plus, a cloud solution, which has an openBIM or which has an open API. And here we have Allplan Bridge, which is a parametric solution, a parametric BIM solution. So for our case, let's say we start in Allplan and we set up the project, we define the project setting, attributes, and so on. Then from here, using Allplan Road, we can start from point, cloud, or terrain definition, and we can start defining the alignment. And this alignment could be exported to Allplan Bridge, or it could be exported to BIM Plus, and from BIM Plus to Allplan Bridge. But regardless, it could be exported in either way. Here, maybe one important thing to notice is that you can also import from third party, maybe from other solutions, directly the alignment to Allplan, and from Allplan you can export it to Allplan Bridge. Or if you want to use just BIM Plus, you can also use BIM Plus, because you can share the project via an email with other clients or other stakeholders, and this could be maybe beneficial for that workflow. Regardless, you can import it to BIM Plus, and from BIM Plus to Allplan Bridge. In Allplan Bridge, once you have the alignment or the axis, you can do the parametric BIM modeling. As it is a parametric solution, so it allows you for faster and easier design iterations. And in Bridge, we can do the design, and we can say, okay, we have the bridge model, and we can export the bridge model once we did the modeling, of course. We can export it to Allplan, so basically we're sharing the geometrical model, or we can also share the analytical model to BIM Plus. This analytical model or geometrical model in Allplan Bridge, basically they are originated from a single model. So basically they are the same model, but they have of course different view definitions. This is a geometrical model, this is analytical. Specifically it has loads, supports, and so on and so on. So this analytical model can be shared to BIM Plus, and from BIM Plus, as discussed in previous slides, this could be exported to third-party solutions where, of course, you can exchange the analytical model and make sure or even do the calculation in different solutions. Once you have that and you verify everything is okay, you can come back to Bridge. Maybe if you have to introduce few changes, you can easily introduce them, because it's a parametric solution. Then from Allplan Bridge, you can export the geometrical model, and this geometrical model will be exported to Allplan, and in Allplan, you could do further modeling. Further modeling in regards to adding additional geometries, or in regards to adding additional information, so you could do attributing as well. Once you did that, or you finish everything, you can of course draw the do the quality checks, quality controls, and draw the lessons here in Allplan directly, and of course also start producing the information deliverables. So maybe if you need an IFC, start working on exporting IFC. If drawing layouts and so on are also wished, we also can start working directly in Allplan. Or you can also just export the whole model to a third party, and you can also deal with that and so on. You can of course export it. For example, one workflow would be to export the whole model from Allplan to for example Solibri, and in Solibri you can do a model check if everything is according to the plan. And once you have everything and you verify everything is okay, maybe you want to give a view permission, and they don't necessarily need to have Allplan or any IFC viewer for that matter. You can just export the Allplan geometrical model from Allplan to BIM Plus, and in BIM Plus you can just invite them via email. So since it's a cloud solution, maybe clients or third party or other stakeholders can directly view the model in BIM Plus. So this seems the general workflow, and based on the requirements or based on the scenario, you can start with either, but regardless, you can benefit from this close integration between all these solutions, or basically the ecosystem. So this brings me to the final slide. Here I will depart you, and I'm very pleased that you all were able to join, and till next time, goodbye.